So we're going to use all the inverse stuff we learned in 8.1 and /2 to solve trig equation 8.3. So we needed a theory in order to solve these types of problems. Okay. So solve the equation for sine theta plus 7 equal to 9. We didn't start 8.3, right? I'm trying to remember.
No, we didn't.
Okay.
We're in the middle of 8.2.
Okay. I think we finished 2. Let me check.
Yeah, we're going through cos theta, I think.
Let me check one moment. Yeah, we did the stuff with the U and the triangles. Yeah, I think that was pretty much it. Sine cotangent. Yeah, I think that was, we're good on 8.2. Let's move on to 8.3. Okay, so what we're solving for is theta. The theta is inside here. So that'd be 4 sine theta plus 7 equal to 9. So what you have to do is isolate the sign, because you can't just divide by sign, right? The theta is an argument. Kind of like in college algebra, when you had e to the x and you had to solve for x, you had to introduce logarithms, right? Do you remember? Or when you had log equations, you had to introduce the exponential to cancel them. So similar idea here. So we have sine. So eventually I need to introduce the opposite of sine, which is sine inverse, to cancel sine. Okay, so first thing you do is isolate sine. So I'm going to subtract 7 on both sides. So you have 4 sine theta equals to 2. Right, 9 minus 7. Divide by 4, both sides. So that would be sine theta equal to 1/2. So now sine is isolated. So we want to know what angle makes this a half. Okay, and they have to give you this information. So let's say part A, solve it on the interval (0 less than theta less than 2 pi). B, solve it for all theta. Okay, so part A means I'm restricting it to the first period. So your homework is going to look something like this. They give you an equation, and they're going to ask you to solve it first on this interval. So when is sine equal to 1/2 between 0 and 2 pi? Okay, so for part A, let's do that first, I guess. So sine theta, we already solved for it, so it doesn't do much anymore. We will do sine inverse of both sides here. So this will undo the sine, like we said last time. So we have theta. Sine inverse of 1/2 is going to give us 30 degrees. Okay, now you find the coterminal angle, because there's going to be 2 places, right? It gives you a half. So let's find those places. Let's use a circle so you can see what's going on. And then I'll show you that you don't need the circle, technically. So we know that sine is equal to 1/2 at 30 degrees, right? The y value. Now, the other one would be over here. So 180 minus 30 will give us this angle. So this is our, not coterminal, what did I just say earlier? Shoot, forgot the name. One moment.
Inverse?
I just said it like 5 minutes ago. Reference angle. Coterminal and reference. Let me see if I can find that picture. Yeah, so one second. Yeah, here it is. So basically, remember we said it was a distance to the x-axis, right? And then we had the that was our reference angle, but then we also had coterminal. So to find the coterminal angle, you do 180 minus the angle you find in the calculator. So this one will be found with your calculator. So we'll call that theta 1. So theta 2, which we know by looking at the circle is going to be 150. But let's say that this is a weird number, and you use your calculator to get it. So that would be 180 minus 30, which is 150. Okay, so those are two angles that will make sine equal to 1/2. So there's two solutions for that equation that they gave us. One at 30 and one at 150. And that's only if you restrict your the period one revolution from 0 to 2 pi. It's one period. But if you say for all theta, meaning there is no restriction, so for part B, what you have to do, so the first set of solutions, so theta 1 would be 30 degrees, sorry, plus, I think it's 2, the book likes to use K, I believe, yeah. 30 degrees plus 360K, or pi over 6 plus 2K pi. Or 2 pi K, whatever, same thing. Theta 2 would be that would be same thing, 150 plus 360K. Or in radians, that would be 5 pi K, 5 pi over 6, sorry, plus 2 pi K, or 2K pi, whatever.
Where's the K coming from?
Yeah, let's explain what the heck K is, right? Let's see, right here. So basically what it means by all theta, it means that I can go around and around K times. So if K is 0, well, that means I only went straight here, right? So look at the angle, right? 30 degrees is there. If I add 1 360, I end up back here, right? So that'd be 1K, 1 360, 2 360, 3 360, 4. So 4, depending on how many revolutions, that's what the K stands for, right? How many times I'm going around. So where K is an integer, so any integer, meaning there's infinite number of solutions for part B. You have a set of infinite answers. Does that make sense?
Yes.
Okay. So whenever they ask you for, whenever they say this for part A, you're just gonna look at the, you'll just have a couple of answers. When they say for all theta or they don't restrict you, then there's going to be an infinite set. Okay. And so the first few will be pretty straightforward like this. Let's do another one just like it. 1 second. Okay, do example 2. The same question, just solve for theta. Solve the equation 8 cosine squared theta equals to 6. Okay, so part A will be solve for theta on the interval 0 to 2 pi. So it's the same thing as using bracket 0, 2 pi, parentheses, right? Using the interval notation. So basically, you'll just solve like we did before. So here we go. 8 cosine squared theta is equal to 6. So you'll divide by 8. So cosine squared theta is equal to 6 over 8. That would be what, 3/4. Is that right?
Yes.
So we've isolated cosine, but we have a square on it. So we're going to have to square root both sides. Meaning we're going to have a plus or minus. Okay? So square root both sides creates this plus or minus. That's the rule for square rooting both sides. So cosine theta is equal to plus or minus square root 3 over 2, right? You guys follow me on the algebra here, or any steps that don't make sense?
Can you explain the second to last?
Here?
Yes.
Yeah, so, okay. So basically what happened was we had square root of 3 over 4, right? So what you can do is separate the square root. The square root of 4 turns into a 2. So that's why I have this here.
Okay, that makes sense.
Okay, so now that we have two answers we need to find. So basically we have, so this means, right, cosine theta equals square root 3 over 2, or cosine theta equals negative square root 3 over 2. So we have two different answers, and each of those answers have probably two locations, right? Well, you can look at the circle right away, so you can see what I mean. Here it is. So where is cosine positive square root 3 over 2? Well, we have one at 30 degrees, right? Pi 6. And we have another one over here at 11 pi 6. So there's two solutions for positive square root 3 over 2. Now the negative one is one over here, and another one over here, right? So we can write those down real quick. So we have 1 theta equal to pi over 6, another theta equal to, where is it? 5 pi over 6, theta 3 equal to 7 pi 6, and theta 4 equal to 11 pi 6. Switch back. So part A, for one period, going around the circle only once, you'll have only 4 answers. But if you don't have the restriction for part B, find all solutions for, they'll word it different ways in the homework, but essentially this is what they're asking. Right? So we're going to have theta 1 equal to, let's put our circle again. Well, it's fine if I write it this way. Pi over 6 plus 2k pi. Theta 2 is 5 pi 6 plus 2k pi. Theta 3 is 7 pi 6 plus 2k pi. Theta 4 is 11 pi 6 plus 2k pi. So you just tack on going around the circle over and over again. Technically, you can probably condense those into 2 answers because I could land on, for example, you see pi 6 is right here. If I add pi, I'll end up landing on this one. So I could just say pi 6 plus multiples of pi, meaning I can go this way, right? Instead of 360. So technically, I can rewrite these this way. I could say there's only really 2 answers. Pi 6 plus k pi, right? And 5 pi 6 plus k pi. Technically, both answers are right. Doesn't really matter. What matters is what the homework is going to ask for, or how they want it. Let me see.
Do we have to put it in the order as like we have it? Theta 1, or theta sub 1 is pi 6, and then it goes like it increases that way around the circle.
You're wondering if they want it in descending order or something?
Yeah.
I mean, it's not necessary. Let me see what they asked for.
No, you didn't have to do it. You just put a comma.
Do they care which one's first?
No.
Okay.
Cool. Thanks.
Thanks. Yeah.
You know, like on the first one for B, like it has the 4 answers, but then you said, or it could be that answer depending on how they ask. How do you know how to differentiate how they ask?
That's what I'm trying to look up real quick. I'm looking at the homework just to be safe. 1 second.
Okay.
I want to make sure it's clear how they ask it. I mean, I hope they should accept both. I would probably go with the first one just because that makes a little more sense.
Okay.
But from what I'm looking at, they don't really specify. They say just put multiples of k, whatever pi you choose in the homework. So they don't specify anything. I would say just try the one that makes sense to you, and let me know if they don't accept it, and I can fix that for you. Okay. I see the next one. So the next one is a little harder because it's no longer a regular theta. It's not even. It's going to be a 4 theta. We'll do a couple of these because when you have this over here, here they're going to tell you solve the equation on the interval. They're not going to have an A or B, but it helps to do the general solution first to guide you. On the interval 0 to 2 pi, or if you prefer. Number 8. Okay, so here's the equation. So let me show you what I'm talking about. We have 4 theta equal to 1. So first thing we should do is look at the circle and give us an idea. So we know that sine, regular sine, not 4 theta, is equal to 1 at pi over 2, right? So technically, I could say, well, I know that the theta, whatever theta is, should be equal to pi over 2, right? Plus the multiple for the general solution. So I know theta should be pi over 2, but I have a 4 on there. What you have to do is divide everything by 4 to get the real answer. That looks weird. Hold on. Pi over 2 divided by 4 plus 2k pi divided by 4. If you prefer, we could say it this way if this is confusing. 1/4. It's a little arrow. 1/4. See what I mean? Just divide both sides by 4. In other words, 1/4 on both sides. Maybe that's prettier than this. This looks kind of weird, right? Because of the fraction. So 1/4 times 4 theta, that would simply give me a theta. 1/4 times pi over 2 gives me a pi over 8. 1/4 times 2k pi would give me pi k over 2, right? Does that make sense? So just divide by 4 each one. So now we have the solution set. So general theta is equal to pi over 8 plus pi k over 2. The issue, okay. Maybe write that prettier. So you're going to use this piece here to find the solution sets, the actual finite answers. So we're going to use this as our guide. Okay. So so let me show you the issue graphically so you can understand what the hell's going on. Because right now it seems a little weird. Why is it different than the first one, right? That we did. So that 4 theta messes it all up, makes it harder than it needs to be. And this is why. Okay. The sign right now. So from 0 to 2 pi, so since it's 4 theta, that means it's 4 times faster than the regular sign, right? In case you forgot, this is the regular sign. See how this one takes a little longer to finish one period, right? Starts down here, goes up, down, and then back to that starting point. So this is one period. This is 2 pi, one entire circle, going around the circle on your unit circle. But look at the red one. It goes up and down multiple times before it even gets to 2 pi, right? You see how 2 pi is like way over here. So here's multiple periods. So there's 1 period, 2 period, 3 period. So it basically repeats itself 4 times within 1 360 degrees, right? 1 revolution around our unit circle. So because of that, we're going to have a lot more solutions. Does that make sense? So look at our question again. It said solve the equation on this interval from 0 to 2 pi. But since this guy repeats itself many times within this range, we're going to have many solutions. So what you're going to do is let k equal to 0, 1, 2, 3. So it's always going to be 1 less than whatever the heck is inside here. So it's a 4, so we'll go up to 3. Okay. 0 would obviously be just pi over 8. So let's go through it. Okay. So k equals 0. Theta 1 would be pi over 8, right? Because this would 0 out. You put the 0 here. Do you agree? You see what I mean? Let k equal 1, that'd be the next solution. It'd be pi over 8 plus one of these. So pi 8 plus pi over 2, what's that going to be? 5 pi 8s, yeah, 5 pi 8s when you add your fractions. So there's one answer. Here's another answer. So now I gotta let k be 2. So theta 3 is equal to pi 8 plus 2 of these guys, because k is now 2. So add these fractions, and you're going to get, let's see here, k equals 2. Yeah, so these 2's cancel. You add the pi to the pi over 8, that would be 9. Oh, thank you, 9, right? You startled me. Sorry, no, yeah, I'm glad you told me. Makes me feel better. But yeah, there's another one. Do you see what's happening, guys? Does that make sense? All right. So since sine 4 theta is 4 times faster, we have to find all those little solutions. So in case 3, which is the last one, the fourth solution would be pi over 8 plus 3 of these. This time I'll show my fractional work, just so you know what I'm doing. So that would be 4, right? Pi over 8 plus 12 over 8, 12 pi. That would give us 13 pi over 8. There we go. So our solution set, so what you would do in your homework, you would put this first one, right? Next one. And just put commas. And that's it. So as soon as you see that 4 theta or 2 theta, that gives you a hint that there's going to be a lot more answers. Okay. If it's sine 2 theta, then you would have to let k range from 0, 1, and that's it. But if it's 3, you do 0, 1, 2. It's always one less. Does that make sense?
Where did the 4 over 4 come from?
So this is me showing our fraction work. So in order to add these two fractions, you need this common denominator. So I need to make an 8, right? 4 times 2 gives me the 8. 3 times 4 gives me 12, and now I'm allowed to add them. Gives me this. I didn't show any fraction steps over here. I showed it on the last one, just in case people are wondering where these numbers came from. I know sometimes we forget fractions. Okay. Let's do another one like this one. This time we'll do a 2 theta, so it'll be not as many, but well, actually, it will be. So okay. So you remember on the question before, where was it? The first question we did, right? We did degrees just so it's a little easier, but when we got to sine equal to 1/2, we found that there was 2 locations for that, right? Using the 180 minus 30. So on the next question, we're going to have a similar situation. It's just that we're going to have a 2 inside the angle. So example 4, I'll show you what I mean. So solve the equation on the interval zero is less than theta, less than 2 pi, or which means the same as bracket 0, 2 pi parentheses. Okay, so cosine of 2 theta is equal to 1/2. So we have 2 locations where this happens, right? So let's look at the circle so we can figure out, it can help us out a bit. So cosine is positive 1/2 at pi thirds, right? And positive 1/2 at 5 pi thirds. So I'm going to set the 2 theta equal to these 2 angles. All right. Okay, so 2 theta is equal to pi over 3, 2 theta plus 2k pi is equal to 5 pi thirds plus 2k pi. Divided by 2 both sides, that would give us pi over 6 plus pi k or k pi, whatever. This would give us 5 pi 6 plus k pi or pi k, doesn't matter. I skipped the division, but you see how I divided every single piece by 2, right? Is that clear or no? Okay. Okay. So that's the easy part. The annoying part is we're going to have to let k be 0 and 1 for both sets. So you're going to do it twice. So let k equals 0. So theta 1 would be pi over 6 plus 0. And then look at this guy over here. Theta 2 would equal 5 pi 6 plus 0. So there's my answer, right? My first two answers. I'm using these pieces. I'm letting k be 0 here. Right, so they would be gone. You see what I mean? So then let k equal 1. This would be the last one. So theta 3 would equal pi over 6 plus 1 pi, because it's 1k. Theta 4 would equal 5 pi 6 plus 1 pi. Okay. So then just simply add the pi's, right? So it had to introduce 6 over 6 on the pi in order to add the fractions. That's the LCD. You get pi 6 plus 6 pi over 6, 5 pi 6, which plus the same thing, 6 pi 6. So my two answers will be 7 pi over 6. That's one answer. This one will be 11 pi over 6. So there's my 4 answers. So theta set, the set of answers or solutions would be pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Is there any questions on how we do this? Does it make sense? Okay. So you'll have, so the first few questions will be just use the calculator or use a unit circle. Subtract from 180 if you need to. Or you'll have stuff with double, quadruple, or triple angles, or you'll have to find these sets of solutions. So that'll be the second type of problems. And then the last type will be questions that require factoring. Questions like this. So solve the equation on 0 to 2 pi. Okay. So you need to treat this like a quadratic equation because that's what it is. That's what it is. See how they have a cosine in common? So you factor the cosine. So now we have 2 cosine minus 1 as a factored, once you factor cosine theta out. Oops, that's not a theta, it's 0. So when you solve quadratics, once they're factored, remember back in this was like middle school maybe, when you have 2 things that are factored equal to 0, you can set each part equal to 0, right? Way back in the day. So now you have 2 equations you have to solve for. This one's not too bad, right? This one we still got to do some work. Gonna move the 1 over by addition and then divide by 2. That gives us this. So where is cosine equal to 0?
3 pi over 2.
Yeah, 3 pi over 2, and where else?
Pi over 2.
Pi over 2. There's 2 of them, right? So we have theta 1 equal to pi over 2 and 3 pi over 2. And where is cosine equal to 1/2? Right? We have
Pi over 3.
pi over 3 and
5 pi over 3.
so here's our solution set. So theta is equal to pi over 2. This is what you would put in the homework with commas. So you treat it just like you would any quadratic equation, right? You factor it, set it equal to 0, and then you have questions like the first 2 we did. Very similar. Any questions on that? Okay, let's do another quadratic type. So what I want you to see is that this is the same as a quadratic equation. Instead of x, we have sine theta. So let's let x equal sine, right? So you can see it more clearly. This is 2x squared plus 3x.
Oh, can you bring the paper up, please?
Oh yeah, sorry. You see what I mean? Replace each of these with x, and you have a basic quadratic equation. And just factor this. Using whatever method you want, when you factor, you're going to get x plus 1, 2x plus 1. But it's not x, so you have to bring it back to sine. So really, we're supposed to say sine theta plus 1 times 2 sine theta plus 1. See how it's the same deal? So then just set these equal to 0 and solve for theta, and you're done. So sine theta plus 1 equals 0. 2 sine theta plus 1 equals 0. So where is sine theta equal to -1? And where is sine theta equal to -1/2? So once you solve, you get this. And so theta is equal to 3 pi over 2, right? And this one will be, where is sine equal to negative half?
Seven pi over 6. And 11
pi?
pi.
7 pi over 6 and 11 pi?
Yes, sir.
Okay. So our solution set will be 3 pi over 2, 7 pi over 6, 11 pi over 6. Do you have any question on this example? Okay. Okay. Well, that's pretty much all for 8.3. Let's take a short break, I guess, and then we'll start page 4, I think. Let me see. Yeah. All right. 7:01. Let's come back at 7:10. All right, guys. Everyone still here? I forgot if I said 7:10 or 7:15. Can't remember.
Good job.
Okay. All right. So you're gonna need all your identities for this next section. I hope you have them handy. If not, I'm gonna find some for you. This will be fine. I might have sent you a PDF a while ago. I don't remember. Do you guys have the PDF?
Yes, we got it.
Okay. So yeah, just open the PDF of the identities if you have it. If not, I posted a link. It should be somewhere. I can't find it. Can't find mine, but it's the same thing. Okay. All right. So basically, this next section, we're not really solving anything. It's a section that makes you learn all the identities and get comfortable with them. So it helps to have them handy. And I'll write down which identity I use on each question. So example 1, all the questions in this section, honestly, the homework, it'll be better to do these on paper than in the program because you need to do every step. Sine theta times cotangent theta is equal to cosine theta. So the idea is prove that this is true. So you pick a side and you try to do algebra or use identities to get to the other side. So I advise that you pick the hardest one, a more complicated looking side. So I'm going to pick this side. Okay, and then I'm going to use the quotient property that basically says that cotangent is equal to cosine theta over sine theta. So from here to here, I used the quotient property. So then these will cancel, right? So that will leave you with cosine, which is what we wanted to see. So from here to here, we just did some algebra. Does that make sense what we're trying to do? We're trying to get to the other side. We're establishing that this statement here is true. Okay, let's do another one. This sounds a little harder. Cotangent theta plus tangent theta is equal, oh, oops, forgot one piece. Times sine theta is equal to secant theta. So I'm going to pick the complicated side and try to get to secant. So I'm choosing this side.
Lift up your paper, please.
That's true. Good. Okay. Yeah, let me get this closer. Easier. Okay. So what we're going to do is use the quotient property to change these into quotients. So I'm going to change this to cosine theta over sine theta plus sine theta over cosine theta. So from here to here, I use quotient. Okay. Now I'm going to add these fractions. So in here I have two fractions, right? So we're going to add those up. So we have an LCD of sine and cosine. So this section will require you to be good at fractions because you're going to have to fix this. So the LCD would be sine cosine. So multiply the first fraction by cosine, multiply the second fraction by sine. And then out here, you still have the sine theta waiting for you.
Why are you multiplying it by like cosine and sine?
Because that's the LCD. Because see how the bottom is sine and the bottom is cosine? So the LCD would be sine cosine.
Okay.
So right here, you'll see it a little bit better. So on top we have cosine squared theta over sine theta cosine theta. So you see how they have the same denominator now? Sine theta cosine theta. So now you can add these fractions. And these are all technically equal. So add the fractions. So we're going to get this. And all I've done so far from here to here is algebra. Add, let me write that better. So now that I've added the fractions, now I can forget my sine is still here. Cosine squared plus sine squared, that's equal to 1, right? That's the Pythagorean identity, the original. Right, looking at your formula sheet, sine squared plus cosine squared is equal to 1. So that's where this came from. And then, on the next step, you have sine on top. You can multiply it in now. Over sine theta cosine theta. So these cancel, leaving you 1 over cosine, which is really secant, which is what we wanted to show. So from here to here, we did Pythagorean. So we did all this work to show that the left-hand side is indeed secant. Okay. Do any of the steps not make sense?
The answer is the bottom line or secant theta, or what's the answer?
The answer is all of it. We're showing that we can get from this side, right here, all the way to secant. So this proves, all this work here proves that it is secant. So we're trying to establish that the first part is indeed equal. So this section wants you to prove it. So you use all your properties that we've learned so far to establish it. So I recommend having that formula sheet out. So a lot of the there's different techniques, but you'll start to see some of that repeat. You'll see that adding fractions helps you out. Changing into a ratio or a fraction helps you out, like with the first one. Stuff like that. So you're gonna do a lot of fraction work in this section. Let me do another one. It's a little easier, I guess. So establish the identity. So that's what we're trying to do. We're not solving for anything. We're just showing that it's true. Sine theta cosecant theta minus sine squared theta equals cosine squared theta. So you pick a side, and then you show that you can change it into the other side. So I'm going to pick the complicated looking side. I'm going to start here. Okay, so, and there's no one way to do this. You basically decide, okay, let me try this out or let me try that out. With experience, you start to see certain things that might work, but there is no one path. You can take many paths to get to the cosine squared here, whatever is on the other side. So I'm going to choose to change this cosecant into its ratio of 1 over sine, the reciprocal identity. So right here, from here to here, we use the reciprocal property or identity, whatever word you want to use. So sine times 1 over sine, of course, will cancel, right? Leaving you with 1 minus sine squared. From here to here was just simply algebra. Now, what is 1 minus sine squared? In your identity page.
Cosine squared.
Yeah, so you see how what we're trying to do, right? And that's Pythagorean identity. So we showed that it is indeed equal to cosine squared. Are there any questions on number 3? Let's do a couple more and then we'll call it a night, I suppose. I'll let you think about this because this takes a lot of practice. Okay. So cosecant x plus cotangent x is equal to sine x over 1 minus cosine x. I'm going to choose the, let me guess, the left-hand side, see how that goes. So cosecant is the same as 1 over sine x, right? Cotangent is the same as cosine x over sine x. So from here to here, we did the quotient property.
Can you erase the paper, please?
Oh, thank you. Okay, but now this time we got lucky and they have the same denominator. So we can just go ahead and add them together, add the fractions. We don't have to introduce anything weird. This will become 1 plus cosine x over sine x. So that was just add the fractions. Okay, and I'm trying to get to this. Looks like I'm almost there, except it's upside down, but whatever. So a good idea to try is to multiply. When you see 1 plus cosine, something like this, is to multiply by the conjugate. So this is one of the techniques that you try out other than adding fractions. So one technique so far was add the fractions or change them into fractions and see if something can combine. This technique here is called multiplying by the conjugate on top and bottom. So the top part is the difference of squares, right? You see that? 1 plus cosine times 1 minus cosine. It's going to become 1 minus cosine squared x over sine x times 1 minus cosine. I also recommend not to multiply everything because stuff may cancel. Don't multiply it right away. You see how I left it this way? So now, what is 1 minus cosine squared?
1.
Sin x, sine
Yeah,
squared.
sin x.
Yeah, this is sine squared, right? So sine x times 1 minus cosine. So these signs will cancel, right? Leaving you with sine x over 1 minus cosine x. And that's what we wanted to show. If you need, I don't want to add an extra note. This was the Pythagorean right there. 1 minus cosine is sine squared. 1 minus cosine squared. Is there any questions on any of the steps for number 4? So far we have tried changing it into fractions. Try adding fractions and see if that helps you. Try introducing a conjugate. Honestly, on all these problems, you just need to try something. Like when I first started doing these, I just look at a problem and say, you know what, I don't know how the heck to start, but I'm going to try this and see if I can bump into a identity on my sheet. That's what I want you to do. And after a while, you'll see, after doing a bunch of these, you'll start to see, okay, certain techniques can help me in certain situations. All right, let's do one more. You guys okay on number 4? So established on the exam, this is what I want to see is just step by step. How'd you get there? One minus cosine x over cotangent x minus cotangent x over 1 minus cosecant x equals 2 tan x. So clearly we're going to pick the left-hand side because that is more complicated. If it's too simple, you won't have any, it'll be a lot harder to turn tangent into this. You see that? Because this will require a lot of creativity. Over here, we can kind of already think, well, maybe if I add these together, something will happen. Over here, I have no idea what to do. Okay. You see what I mean? So I'm going to start on the left for that reason. So what is the LCD of these two fractions? They do not have the same denominator. So I need to multiply top and bottom on both of them to create an LCD. LCD about 95% of the time will just simply be this piece times this piece for these types of problems. In this class. So we can almost always, not always, but almost, just say LCD is these two pieces. So to make the bottom look like this one needs 1 minus cosine. or cosecant. This one needs cotangent to turn it into this. That's why I multiply the top and bottom the way I've been doing it, right? So top and bottom times the piece it needs to complete the LCD. Now the other piece. This one needs a cotangent down here. So equals. So this will be 1 minus cosine x. 1 minus cosecant x over double check this question. Oops. Yeah, I made a mistake. Sorry. Not a big one. Don't worry. This is not cosine. This is supposed to be cosecant at the very beginning. So wherever you see cos, put cosecant. Sorry about that. They kind of started blending together in my head for a second. So the way I think about this section, a lot of students, I mean, in every class, I think most of the students struggle with this section at first and they hate it because it requires a lot of practice. And I like to think of it as a weird game. I have these rules that I've been given, and I need to get to the other side. It's like some strange Sudoku or something. Okay, that's basically what we're doing. And the rules are the identities and our algebra. If you remember all that, then you can play this game.
Wait, isn't that all of math?
Pretty much, but this one especially. But yeah, you are right. Except a lot of the time in math, we're solving something. Here, we're just playing. We're not solving anything. When you get to higher level math, most of the time you're just proving things are true. That's how formulas are made in theorems. You have to prove them using logic. Okay, so here we go. Now we're good. So this times this. Minus this. So now they have the same denominator, so I can combine them into one. But also notice that the top parts are the same, right? So those are going to be squared. So you're going to end up with, on top, 1 minus cosecant x squared over this denominator. And we'll show us extra step here. There we go. All right. So combine the fractions. So you see the top parts are just multiplied, giving me a square. So this will be 1 minus cosecant x squared minus cotangent x squared over the same common denominator. Cotangent x times 1 minus cosecant x. Okay. All right. So all of this here so far had fractions. There was not anything special. Okay. It's just that these fractions are nasty. They're not usual fractions. They're more like rational expressions. So now we have to distribute this or multiply it out, or FOIL, however you want to think about it. So this would be 1 minus 2 cosecant plus cosecant squared x minus cotangent squared x. That's on top. Bottom is the same stuff. You see how these questions can get out of hand right away. When you're doing these in your homework, sometimes you'll try different things and you'll realize you'll hit a dead end. It's possible that the path you took was complicated. Sometimes just start over and try something different. That'll be better. Or maybe if you just need a couple more steps and you'll get there. It really depends what's happening. There's been a few times where after I finish, I realize, you know what, I could have done it in 3 steps instead of 7. So anyway, keep going. So -2 plus, let's see, does anything cancel here?
Where did we get the 2 cosecant?
Well, that's from the multiplying this out here. So 1 minus cosecant times 1 minus cosecant will give you 3 terms.
Okay.
Hold on. I forgot. I think I forgot something. Oh, I see. So cotangent. So this is when we have to start getting creative, because right now all we do is add fractions. So you notice how we have nothing but cosecants, right? Then we have a cotangent. So we need to change cotangent into a cosecant type of problem.
But if we have the 2 cosecant, why do we have plus cosecant squared? Isn't it already added in there with the 2 cosecant?
What do you mean? These 3 terms came from
Right.
multiplying it, right? So, but notice how they're all cosecant. So if I change this to cosecant, then I can combine it with one of these and make it a little bit simpler.
My question is, if you put 1 minus 2 cosecant x because of the one above it, why are we adding another cosecant? That's like saying 3 cosecant, isn't it?
Are you wondering where this came from? These 3 pieces? Do you see where they came from? Before we...
No, yeah, I guess I want to know, where did that 2 cosecant come from?
Yeah, let's do it. We'll do it up here. Just real quick. So 1 minus cosecant x squared means 1 minus cosecant times 1 minus cosecant. So 1 times 1, 1 times negative cosecant, and then cosecant times 1. Negative cosecant times negative cosecant is cosecant squared. So when you multiply all this out, you're going to get these terms, which will then become 1 minus 2 of these. You have to multiply this to get the 3 pieces. Okay, so 1 times this one, 1 times that last one, cosecant times this one, cosecant times that one. That's where these 4 pieces come from, which combine into this. So that's where this piece came from. Does that make sense?
Yes, now it does. Thank you.
Okay. Okay, so after this looks complicated, so we need to make this into a cosecant. So in the identity, what is cotangent squared equal to?
One plus cotangent squared equals cosecant squared.
Secant squared is equal to what?
1 plus cotangent squared.
Okay. So we have 1 minus. Make sure there's no sign errors anywhere. Okay, so that means that cotangent squared is equal to cosecant squared x minus 1 if you solve for cotangent. So I can plug that in here. Okay. So 1 minus 2 cosecant x plus cosecant squared x minus the substitution of cosecant squared x minus 1. See what I did, right? We substituted this. So then, running out of space, you get 1 minus 2 cosecant plus cosecant squared x minus cosecant squared plus 1. So these will cancel. Same, the denominator hasn't changed. Then you have 1 plus 1, which will give us 2 minus 2 cosecant x over, I'm just going to write LCD because it's getting redundant. Okay? I'm going to write this on the next page. Do you see how the 1's combine and the cosecant squares canceled, right? All right, let me write this part on the next page. Out of paper. Okay. So right now we have 2 minus 2 cosecant x over the LCD, which is cotangent x times 1 minus cosecant, right? That's what we have at the bottom. So factor the 2 out, and we're left with 1 minus cosecant x over cotangent x times 1 minus cosecant x. So these will cancel, leaving you with 2 over cotangent. But 2 over cotangent is really saying 2 times 1 over cotangent, which is actually tangent, which is what we wanted to show. So you can see some of them aren't too bad, but some of them can get really complicated. It really depends on the question. But please practice a bunch of the basic ones first, and work your way up to something like this, because this is something you do towards the end.
When's our next test?
No, let me see. I can give you an estimate.
And also, where can we find the grades? Will this be in Canvas or in Pearson?
Yeah, I've started putting in grades already. You should see them in Canvas. Let me see. Yeah, I'll actually, yeah, I'll turn it on so you can see them. Just click on assignments or grades and you should see it in a moment.
Okay.
Yeah, I think it's not on right now. Let me fix that.
I know I was checking all spring break, Jack.
Yeah, I guess I didn't turn it on. I'm sorry. No, they're done. I just need to show them to you.
Mm.
Okay. Click assignments and see if that shows you. And if not, let me know. I'll add something else. You'll see a little tab that says assignments. Okay. All right, guys. Well, I'll see you on Thursday, and we'll bring some questions on identities. If you're struggling with it, we can practice some more, and then we'll move on. As far as the test stuff, forgot about that. We're just about done with chapter 8, so maybe we can finish. We'll probably finish chapter 8 on Tuesday of next week, then review on that Thursday. So I'd probably open the test up sometime next week and close it sometime after, maybe around the 31st or after that. Maybe that whole week, I'll leave it open. That's
So
an
we want to
estimate.
explore,
What's that?
the chapters for test 2.
Yeah, we just chapter 8, 8-1 through 8-7.
Okay.
And we just finished 8-4, so 8-5, 8-6 will be next time. 8-7 and review will be probably Tuesday or something. Okay. So there's your estimate. Next week I'll tell you a more hard or specific date, I guess. Okay, so no questions, you can head out, and if not, let me know. I'll be here for a little bit.
Jack, I have a simple question for one of our homeworks. It's for 8-2. I can't understand, like, it says the inverse of secant, and then it's -2 square root of 3 over 3. And I think I'm supposed to find the exact value, or
Oh, what number is it? Remember?
pull it up on a chapter.
I'm sorry?
Hold on, look up.
So the test grade that's on Canvas, does that already include the 10 points that you were going to give us, or not yet?
Yes, it should. But I haven't put it everyone. I think yeah, they're all done, but I need to update the grades. So you should see it updated in the morning, if not tonight. I think
Okay,
80% of the people are already in, but if your last name is towards the bottom of the alphabet, then maybe not.
Okay, thank you.
I think there's like 4 people missing, I think.
I'll email you, Jack, if I did.
Okay, that's fine.
Oh, I'll talk to you on Thursday.
All right, that's good.
All right,
I'll
thanks. Bye,
see you
guys.
later then.